This is 5.6, simplifying radicals. Simplifying radicals. We have already learned the word radicand, or we've talked about it before, but just to make sure, we need to know what that is. So radicand is the quantity that's underneath the radical sign. Again, the quantity underneath the radical sign. So if we've got a radical sign like this, we're looking for whatever's in here, whether it be numbers or variables. And we're going to simplify this the best we can. A radical is simplified when the perfect square factors are removed. Perfect square factors. Now remember, perfect square is a number where you get when you square a whole number. So if I square 2, I get 4. 4 is a perfect square. If I square 16, I get 256. That makes 256 a perfect square. So a perfect square has a whole number square root. A whole number square root. Okay, so perfect square factors are removed. Remember, factors just multiply to be another number, or divide a number evenly. Okay, fractions in the radicand are removed, so I can't have a fraction in this radicand. I can't have a fraction as the radicand. I can't have it in radical sign. And the denominator is rationalized. That means the radical sign in the denominator is gone. It's got to be radical free on the bottom. When these three things have happened, we would consider the radical simplified. So we're going to look at a few ways to do that in the following examples. In example 1, the 6 problems we're going to do in example 1, we're going to simplify radicals that have a whole number radicand, So I'm going to look at 160, and what I've got to see is there a perfect square that goes into that. A perfect square. Now, if we look at perfect squares, 2 squared is 4. That's a perfect square. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared, 36. 49, and so on. These are perfect squares. Okay, but I think it's pretty obvious which perfect square goes into that. If I look at 16, that's 16 times 10. 160 is 16 times 10. So what you do is you take 160 and divide it into 2 factors, 16 and 10. Okay, now this perfect square factor will come out of the square root. This will stay inside the square root. So when we take something out of the square root sign, we get 4, or we evaluate it, we get 4, and then what's left inside stays inside. So the final answer is 4 square root 10. 4 square root 10. Okay, moving on. Let's do number 2. 72. I'm looking for a perfect square that divides 72 evenly. But I want the largest perfect square, not just a perfect square. I know 9 times 8 is 72, but that's not large enough because 8 still has a perfect square that goes into it. And so what I want to look is something larger. And if you don't know what that is, just divide that by 2. 72 divided by 2 is 36, and I happen to know 36 is a perfect square. So that's what I'm going to do. I'm going to divide 72 into 2 times 36. Okay, now remove the perfect square, and then 36 comes out. You evaluate it, and that is 6. What's left inside is 2. What's left inside is 2. Okay, moving on. Let's move down if we can. Let's get a new page. There we go. A little bit more. Okay, 243. 243. If you don't know what to do, you divide. And if we take 3, or if we take 243 like a factor tree, okay, and we divide that by 3, that's going to be 81. Oh, I know 81 is a perfect square because 9 times 9 is 81. So I'm going to divide that up into 3 times 81. Okay, the 81 comes out because it's a perfect square, and when you take it out, you take the square root, you get 9, and what's left inside is square root of 3. Okay, and that one's finished. 125. Well, I think it's pretty obvious what perfect square goes into this. It ends in 25, and 125 is really 25 times 5. 25 times 5. This comes out of the square root sign. You take the square root, you get 5. You leave the 5 in there, you get 5 square root 5. 5 square root 5. Okay, 40. What do we think here? 4 times 10. 4 is a perfect square, so we're going to divide 40 up into 4 times 10. Okay, the 4 comes out, 10 stays in, that is 2 square root 10 for my final answer. 2 square root 10. 500, well, I know that 10 times 10 is 100, so 100 is a perfect square. And that's just 5 times 100. So square root of 5 times 100. The 100 comes out, and when I do that, I take the square root. That's 10. What's left inside is 5. 10 square root 5. Okay, two more here. The 180. Actually, let's go to this one. This one's pretty simple. We'll come back to this one. Okay, 63 is just 9 times 7. Okay, we all should know that. 9 times 7. 9 is a perfect square. You take the square root of 9 to bring it outside, and you get 3 square root 7. Remember, when you evaluate the square root of 9, it comes outside the radical. Okay, if you don't evaluate, it's got to stay in. You got to evaluate it, which is 3. Okay, let's look at this 180 problem. Okay, I know what perfect square goes into it, but you may not. If you don't, you just start dividing. So we're going to do a little factor tree here. Okay, that's 2 and 90. And then we'll do 2 and 45. And then we'll do 5 and 9. And we'll do 3 and 3. Okay, so we look at all the factors of 180. And when you take a pair of their factors and another pair of their factors and multiply all those together, you get a perfect square. That is 9, which is a perfect square, and 4, which is a perfect square, but multiply those together to get a better one. 9 times 4 is 36. And it's 36 times the leftover, which is 5. Okay, so I'm going to multiply 36 times 5. You can do this for any number. If you're stuck, start doing prime factorization, and when you're through, find pairs of numbers you can multiply together. That's a pair. That's a pair. They don't have to be side by side. It just needs to be a pair of them. And then the leftover junk is by itself. And if there's more than one leftover, you multiply those together. Okay, but I bring the 36 out, and that's going to be 6 square root 5. 6 square root 5. And that takes care of example 1. In example 2, we're going to be removing variable factors with the number factors. So when you have a variable with a number, it's just a little bit more work, but not much. So I'm going to look at the 54, and I happen to know that 9 times 6 is 54. 9 is a perfect square. Okay, that's what I want. It's the largest perfect square that goes into 54. Now, x4 is a perfect square also, believe it or not. We don't have to do anything to that. So we write it like this, and we're going to bring out this and this because they're perfect squares and the 6 stays in. So I get 3. And when I bring x4 out, you take half of the exponent. Half of the exponent. Because remember, an exponent of 1/2 means you take the square root of a number. Okay? So this index is 2. That means I take half of that to take it out. Okay? To take it out, I get x squared. And what's left inside is 6. And that is a simplified version of that. See? Variables are pretty simple. Okay, now this one is an odd number. We got to do something a little bit more work to this to make it to where we can bring it out, but it's a pretty easy step to do. So I'm going to look at 9 times 10 for 90. 9 times 10, that works for me. Now with this, I need it to be an even number exponent, not an odd. So the way we do that is very simple. We take 1 out of that. So I put an x1 there. I don't have to write the 1, but I'm just showing you. And then I put the rest here. If I take 1 out of that, I get x1 and x8. Remember, when you multiply, you add exponents, that equals x9. Okay? So when you have an odd exponent, you just take 1 out of it and put the leftover there. Now the 9 comes out and the x8 comes out, and these two stay in. When I bring the 9 out, I get 3. When I bring the x8 out, I have to take half of that, which is going to be x4. Okay, and then you have 10x staying in the radical sign. Okay? 30. Well, I happen to know that 6 times 5 is 30, and neither one of those are perfect squares. There's no perfect squares that go into 30. But I do want to do something here. Okay, I want to change this because 5 is an odd number. I want to make that y4 times y1 because that still equals y5. But I can do something with this y4 and this x4. Those two will come outside, and my final answer here will be 30 x2 y2. I'm sorry, I totally messed that up. Okay, scratch that. The 30 doesn't come out. I don't know why I was writing the 30. x2 y2 on the outside. and then square root 30y1. 30 stays in, and the y1 stays in. Okay? Moving on, we've got 80x4y5, so I want to do two things. I want to divide the 80 up into factors, one being a perfect square root. Okay? So, you can do, okay, let's look. Most people will say 4 times 20, and let's look and see what happens with that. Well, I know 4 is a perfect square, but I noticed that 4 also goes into 20. So if I took the factors of 20, I would have 4 times 4 times 5. Okay? Now, when you multiply two perfect squares together, you get a perfect square. So 4 times 4 is 16. It's 16 times 5. I want the largest perfect square, so I'm going to use 16. Okay, x4 is good. y5 is not good. We have to divide it into 2. It's going to be y1 and y4. Okay, 16 comes out, x4 comes out, y4 comes out. So we get 4 x2 y2 square root 5y. Square root 5y. Let's get a new page. Let's move down a little bit, bring these up. Okay, two more here. Okay, 120. 120. Well, I happen to know that 120 is 6 times 20. It's also 12 times 10, but none of that really helps. Okay, so what can we do with 120? Let's do this and see what happens. Okay, if you don't know what to do, we're gonna prime factor. So that's 2 times 60. That's 2 times 30. Okay. And if you remember, 30 is not going to help us any, but we can keep going. Okay, we get 2 times 15, and we get 3 times 5. Now, I've got a pair right here of 2's. So my perfect square is 4. And then I'll multiply the rest of the junk to get 30. It's 4 times 30. That's 120. Okay? So see what I did? I just circled a pair of 2's. They gave me a perfect square. I multiplied the junk together, and that's 30. Okay, x7 becomes x1 and x6. y4 is just y4. Okay, so I'm going to take out the perfect squares. When I do that, I take out the 4, I get a 2. I take out the x6, I get an x3. y4 becomes y2. And on the inside, what is left is 30x. 30x. Okay, one more here. 76. Let's just look and see what happens. We got 76 divided by 2. That's 38. Divide by 2, 19. 19's prime, and these are pair of 2's is 4. So this is really 4 times 19. Okay, 4 times 19. And then I'm going to divide the x7 into x1 and x6. I've got y8 and z. Okay, all that is under a radical. Bring the 4 out. That's a 2. I'm just going to scratch it out. 19 stays, x stays, x6 comes out as x3. Scratch it out. y8 comes out as y4. And then inside I should have a 19. I should have an x, and I should have a z left over. Okay, and that's how you do it with with variables inside the radical. Okay, let's multiply radicals together. Okay, when you do that, as long as these indexes are the same, which both of these are 2, you can multiply what's inside the radical. But since I really don't want to multiply anything and get something kind of big, even though it's not real big, I'm going to show you 2 ways of doing it. Let's do this one way. I'll do another one a different way, and then you can choose which way is better. Okay, so what I'm going to do is divide that 6 up into 2 times 3, and divide that 18 up into 18 is 9 times 2, which is 3 times 3 times 2. Okay? 3 times 3 times 2. So what we've done is just put the 6 and the 18 together. This is 6, this is 18. I just did prime factorization for both of them. Again, this may not be something you want to do. I'm just doing this a different way. So I've got a pair of numbers. I got a pair of 3's and a pair of 2's. If I multiply the pairs together, I get 9 times 4, which is 36. 9 times 4 is 36, and the leftover is 3. So this is going to be 3 square root 36 times 3. The 36 comes outside as a 6. Now when the 6 comes outside, it gets paired with that 3 and you multiply them. And what's inside is a 3. So that just becomes 18 square root 3. Okay, it just multiplies by the number that's already outside. Okay, again, you may not like that. You can go ahead and multiply 6 times 18 and then find a perfect square that goes into it. In this case, it would still be 36. You still get the same answer. I just did it a different way. Okay, let's do this one a different way. Okay, here I'm just, because they're both square roots, I can multiply them and I get 18a4. 18a4. Okay, well, 18 is just 9 times 2, and 9 is a perfect square. Okay, so it's 2 times 9 times a4, and we're going to simplify that. The 9 comes out and the a4 comes out. 9 comes out as 3, a4 comes out as a2, and what's left inside is square root 2. We got square root 2. Okay, let's clear that and move down. So you can get a little more challenging problems. Maybe so, kind of looking a little better. Okay, we have 7 times 3 on the outside. That's 21. And I'm going to go ahead, I don't know which way you would like doing it. I'm just going to go ahead and multiply them. Okay, maybe next time I'll do it different than that. So 5 times 20 is 100. X times 5, x5 times x1 is x6. Okay, now the great thing is both of these things inside here are perfect squares, so we will not have a radical in this problem. I'm going to bring the 100 out and the x6 out. When I do that, there's already a 21 outside because 7 times 3 is 21. We're going to bring the 100 out as a 10. That gets multiplied, and the x6 out as an x3. Now put all that together, you get 210 x3. Okay, that one actually cleaned up pretty nice. Okay, here let's multiply. You get 6. Okay, now I'm going to take the square root. Now because this is really easy to factor, and 7 is prime, I'm just going to do 7, and 14 is 2 times 7. I'm just writing all the factors. I did it the same way I did the first one. And x times x2, I'm just going to keep them factors. Okay? So I've got x2 times x1. I don't want to put them together because then I have to take them apart again. Okay, now if you will multiply the pair, you get 7 times 7 is 49. Okay, what you really have is 49 times 2 times x2 times x1. And there's a 6 on the outside. Okay? Now bring the 7 out. 7 times 6 is 42. Okay, that's gone. Bring the x2 out as x1. And then leave the 2x1 inside. And that is a simplified version of that. Okay, let's see if we can clear this page off a little bit and go to the last two here. Okay, I'm going to multiply these two and get 12. 5 times 1/5 is just 1. Okay, so inside the radical, that's just 1, and that's going to be M4. It looks really bad, but this cleans up nice. Take the M4 out, and that's M2. So it's just 12 M2. And we're good. Okay, last one here. Well, this looks ugly. We'll see. Okay, negative 8 times 1/4 is negative 2. Negative 2. Okay? Now, I've got a 24 and an 8. I got an x5 and an x9. I'm going to factor them both. Okay? You can go ahead and multiply 24 and 8 if you want to. I'm just going to factor them both. Okay, I know 8 is 2 times 2 times 2. Okay? I know 24, if I factor that, that's going to be 2 times 12. That's 2 times 6. And that's 2 times 3. So it's 3 2s and a 3. And then when I put these x's, I think it's best to put them together because you get an even number. So 9 and 5 is 14. So you get x14. Okay? Now look at all these 2's. I got a pair here, and a pair here. Multiply that together. 4 times 4 is 16. Times 4 is 64. So this really cleans up to be negative 2 square root 64 times 3 times x14. Okay, the 64 comes out as an 8. The x14 comes out as x7. Well, with that 8 and that negative 2, you get negative 16. x7 square root 3. Square root 3. And that takes care of multiplying and simplifying. Okay, 2 more sections. We're going to do some fractions, a little fraction work. Some of these are really easy, some are not. We'll see. Okay, let's get into it. So when you have a fraction as a radicand, you split it up. So this, according to the properties of square roots, this divides into 2, okay, like this. I can take this and divide it into those 2. Well, I know the square root of 64 is 8, I know the square root of 49 is 7, and 8/7 is my answer. Really easy. Let's do this one. Same thing. Split it up, 144 and 9. You get 12 over 3, and that is equal to 4. Okay? Easy, easy stuff. They're not all that easy, but let's take a look and see what we can do here. Okay, let's do some simplifying inside this radical. Sometimes this works really nice, sometimes it doesn't. But if I reduce this fraction by 2, I get 4 over 25. And that works out really good. And if I subtract these exponents, x3 over x1, that gives me x2. And if you'll notice, everything in here is a perfect square. So I take the square root, I split up the square root. Again, I'm just showing you this. You can do this in your mind. And then take the square root. You get 2x on top, you get 5 on the bottom. Okay? And that is all you need. Okay, on this one, we're just going to do one simple thing. We're going to split it up. And on the bottom, when we split it up, we get to divide that A3 into A1 and A2. Okay? So, out of the 36 comes a 6. Out of the 4 comes a 2. Out of the A2 comes an A1. And left inside the radical is going to be an A. Just an A. Okay, so 6 over 2 gives me a 3. I want to go ahead and do that. 3 over A, okay, square root A. Okay, now I need to do something about this. Got to do something about this. So I've got to get rid of the square root on the bottom. The way to do that is to multiply it by something that makes the square root go away. And the answer to that, what that is itself. So I'm going to multiply this square root A by the square root of A. And if I do that on the bottom, I have to do that on the top, okay, to keep the fraction the same. So I get 3 square root A over, now when you multiply square root of A times the square root of A, you get the square root of A squared, which is just A. And there's already an A on the bottom. So you get A squared on the bottom. Okay? And that's how you simplify a radical in the denominator. Okay? That's the only way you can do that. Let's get a clear page and let's move on. See if we can move on a little bit here. Go down. Okay. Up top, I'm going to divide that up into y1 and y2. Now I'm going to bring the 25 out as a 5. I'm skipping this middle step here. Bring the y2 out as a y1, and what we have left on top is y. On the bottom, I bring the z2 out as z. No square root on the bottom, we're good. Just a square root on top, everything's nice. I can't reduce that at all. Everything looks good. Okay, here, let's look at this. I've got square root of 15 over x3. We're going to take square root of 15. We can't do anything with. 15 is 3 times 5. On the bottom, I need to do this in x1. So I get on the bottom, the x squared comes out, I get an x, and what's left inside is x1. That's not acceptable. So what I have to do is multiply the top and the bottom by something that makes that go away, and that's the square root of x. Okay, when I do that, on top you multiply the radicands together because they're inside the square root sign. So I get the square root of 15x on the top. And on the bottom, x times x is x squared, but the square root of x squared is x. So you get x times x, which is x squared. Okay? And that simplifies the radical sign in the denominator, or rationalizes the denominator, as they say, and now everything looks good. Finally, the last set, rationalizing denominators. Most of these are really simple. We're going to look at square root of 3/7. We're going to split it up, okay, like we should. I've got to get rid of the square root of 7 on the bottom. So, to get rid of that square root, you multiply it by itself. So square root of 7 over square root of 7. You're really multiplying something by 1, so you're not changing the fraction at all, changing the look of it. That becomes square root of 21 on the top. 7 times 3, it stays inside the radical. On the bottom, the square root of 7 over times the square root of 7 becomes square root of 49, which we know is 7. So it basically just takes the square root off. You can't reduce that because this is the radicand. This is not. This is just a whole number, okay, in the denominator. That cannot be reduced. So you leave it like that. You're done. Here we have square root of 2 over square root of 3. I want to make that square root on the bottom go away, so you're just multiplying by the square root of 3 over the square root of 3. Square root of 6 over the square root of 9, which is 3. That does not reduce because that's the radicand. That is not a radicand. You can't reduce them. Okay, keep going. Here we have square root of 5 over square root of 18. Okay, so I'm going to do a little simplifying before we multiply. If I redo or simplify that, I can take a 9 out of that because 9 times 2 is 18. Okay, so I can really write that as 9 times 2 and square root of 5 on top. Bring the 9 out, you get square root of 5 over 3 square root 2. Now multiply the top and bottom by square root 2. It's a few steps, okay, but it's not bad. Square root 10 on top. That's going to be square root of 2 times square root of 2 is square root of 4, which is 2. 2 times 3 is 6. Okay, square root of 10 over 6, that does not reduce because that is in a radicand and that is not. Okay, here, split it up. 7x on top, square root of 7x on top, square root of 3 on the bottom. Multiply by the square root of 3, top and bottom. So you get 21x underneath the radical sign. And on bottom, you get square root of 9, which is just simply 3. That does not reduce. Okay, let's clear the page and move it down a little bit. I can't move it down much more because that's the end of my page. That's better. Okay, here's what we can do. We can simplify this a little bit. This is under the radical and this is under the radical. So what I'm going to do, I'm going to simplify this by just reducing. That becomes 1, and if I divide by 5, that becomes 1, and that becomes 3. And the square root of 1 is just 1. So on the top I have 3, on the bottom I have square root of 3. That makes it a little bit easier. Okay, multiply the top and bottom by the square root of 3. And when I do that, I get 3 square root 3 on the top. You can't put those together and get 9 because one's outside the radical, one's inside the radical. Okay, 3 square root of 3, and on the bottom I get square root of 9, which is simply 3. That reduces. That goes down, you just get square root 3. Okay, that cleaned up nicely. Okay, one more of these. Let's simplify this before we do anything. Okay, so one step to simplify, we're going to divide 8 up into 2 times 8, and then x2 and x1. Okay, I'm sorry, why did I do 2 times 8? It's 2 times 4. 2 times 4. It's really ugly, but it's 2 times 4. Okay, I don't want to erase it. We're going to bring the 4 out. So I've got 18 over, the 4 comes out as a 2, the x2 comes out as an x1, square root 2x. Okay, so I get a 2x, square root of 2x. All right, now we're going to simplify or rationalize the denominator, multiply by square root of 2x over square root of 2x. 18 square root 2x over, okay, now let's think about this a little bit. If I multiply this to this, you get 4x, the square root of 4x squared, which is simply 2x. But I already have a 2x there. So these go together to equal 2x, and it multiplied to that 2x, I get 4x squared. 4x squared. Not done yet. Of course not. We can divide the 18 and 4 by 2. So get 9 over square root of 2x, or 9 square root of 2x, over 2x squared. Okay, it wasn't pretty, but that is the answer to that, and that sums up simplifying radicals.